Well, it's a horrible rainy night, but the new charge controller is here. Okay, so positive to positive, negative to negative. Right, so it looks like we've got some initial setup to do. I will not be installing this tonight, I don't really have time, but just to ensure that it does work. These are just two little 7Ah batteries in series. Now look at the size of the transformer inside that. That is absolutely huge. I'm pretty sure that's a ferrite cored one. Most likely will be. I'm pretty certain it will be. But yeah, that's a pretty serious size transformer. This is a FlexMax60 solar charge controller, so I'll have 60 amps going through it. I will not be opening it up any further, as I do not want to void the warranty or anything like that. If anything goes wrong with this, it'll be straight back to the seller, as it was pretty expensive. I think it's about £420. So going by my first impressions, it seems very, very well built. So we'll just have to see how it gets on. I will be planning to set it up with a dump load, because you could use that aux out port to do that, but I'm going to have to figure out how to drive MOSFETs with it, because solid state relays I could find are pretty slow, 10 milliseconds, and that's no use. Right, okay, so the first thing to do is select the language. So you'd press the select button, I think. Right, that's fine. And you have to enter the password. I think it was 14 something as a default, but I'll give that a try. I think I'll have to do a bit more reading on it, because I think you have to actually change the password. I think it was 141, I'm sure. Right, there we go. Right, so system voltage. It's going to be 24 volts for me. So I think you just press enter there. Go to yes. There we go. Now it's saying there's an input voltage, which is strange because there's nothing connected to it, but I don't know. I think what I'll have to do now is actually set up the battery voltage as well, to make sure it actually charges them properly. So it'll be quite a learning curve there. It's a bit off topic, but in another one of my videos I mentioned that one of my batteries had a weak cell, and I had a kind of a rotten egg smell to it. But the specific gravity's gone back up on it. And that's really good. It seems to have come back a lot. It would never go above 1.27, but now it's right up at about 1.28 where it should be, so that's pretty good. It must just be because I've had these batteries sitting at like 30.5 volts for like several hours during the day, because I've had to change the solar charge controller. I can't have a load on the battery all the time, so it's kind of a good thing. It's reconditioned them really well. I think these types of solar charge controllers are actually better for the batteries than dump load charge controllers, like the kind that actually have it like dumping for like a second at a time, then it's off again, because it's kind of microcycling the battery. So while that MOSFET is on dumping power into here, it would be pulling 1000 watts for the battery from the battery for an instant, and I don't think it was very good for it. Even though the average battery voltage was very high, even for a long time during the day, I just couldn't get the specific gravity up. So these types of charge controllers, it would seem, are better for the battery. So this one should be good for the battery too. I'm going to take it inside and just connect the output up to a power supply and just play around with the menus. When I get my time off work, on Wednesday night I could get this set up, and then we'll see if it's working in the morning. So I'm ready to mount it now, but I'm not that sure where to put it. I can put it up there, and then the camera can have a view of its screen, so I know exactly how I'm producing, but then I'll have to get rid of these current meters and stick them somewhere else. Or then I can put it there, but the camera's probably not going to be able to see the screen, so I'm not sure how good to think about it. These solar panels I'm going to have to be rewired. I can't connect them all in series, each side in series, because in winter that could result in the open circuit voltage being very close to 150, which could damage the controller. So I'm going to I'm going to wire them in groups of 3 and put that in series, so I'm getting about roughly 70 volts open circuit, so it's a bit safer to work with. The way these panels is wired is quite wasteful on wire, but then again it's very versatile because each panel has its own wire coming into the shed, so that means I could rewire it however I want. Just in case this solar charge controller fails, I could quite easily set it back to the lower voltage. I'm just redoing my wiring diagram because I have rewired the panels outside. So before, these two panels which coming in there were just a single panel, but they're actually two panels in series, so I'm just trying to get it set out clearly before I start rewiring. So now that's a diagram of all the panels drawn out, so I can make better sense of it. And all the wires are out as well, so I'll have to get these all rewired. The way I'm going to do it is these three will be in series like that, and then these three will be in series, and then they'll go into parallel, and the same on the other side. And then once I've done that, both sides will just go into parallel. Well, that is now everything all wired up. That is just a 10 gauge wire. I reckon it'll be handling about maybe 16 or 17 amps maximum, so it's a bit better. I can make the wire a little bit thinner, and that's it. As for this auxiliary output, it can actually be used to control a dump load in PWM mode, but it's outputting about 13 volts. I measured it a while ago, and I'll need to figure out some way to drive a bank of MOSFETs with that, 4 MOSFETs in parallel, and the dump load will be the air conditioner, and that should hopefully keep the shed a bit cooler in summer. Another thing about the grounding, it's got a bit here you can put an earth wire on, so the casing is not in any way connected to the battery and solar panel negative or anything negative on the circuit board. It's only the casing. Another thing, the negative of the aux output is actually electrically connected to the negative inside, but not to nothing, and none of the electronics is actually connected to earth. So the negative of that aux output is not isolated. Just now I've got it set to nightlight mode, but I don't actually have anything suitable to plug into it just now, just as a test. So when the solar panels get down below 10 volts, or whatever volt you choose, for whatever time you choose, that'll switch on. It has a whole load of settings on it, hundreds of menus and settings. You'd have to read through it yourself, but it seems to be pretty good. This meter here is for just my other load connection, where I can connect things up like battery chargers and stuff to a maximum of 50 amps. I think that could just be mounted under here. I'm going to stick it on with some glue and that should do it. So I'll be able to just pan the camera between the screen here and my meters, or I'll maybe move the camera back as well, because I think that's a bit too close. But these watt meters in general, they're very buggy, and you'll be lucky if you can find a good one. This one, for example, the day I came home, yeah, it showed the watt hours and everything correctly, but it showed that I'd only produced like about 1.5 amp hours when I produced like 2000 watt hours. So they've all got their own problems. The only thing I'm not sure about here is if we go to the login screen, it's a voltage readout. It only does it to 1 decimal place. It is accurate, yes, but it doesn't do as many decimal places as my little LED voltmeter here. So I'll still have to use that to get an exact idea. But yeah, I've measured it in comparison to my multimeter, and it is very accurate. So here it's saying 25.4, and it's saying 25.4 on the screen down there, so that's a vast improvement for here when I think it was out by about 0.8 volts, which is unacceptable. Another thing to mention is the power consumption when this thing is idle. So it seems to be only about 30 or 40 milliamps, so nothing major.